Okay, welcome back. This is part 4. We're going to work on problems 9 through 21 in the packet. Remember, it's that second chunk of problems, 9 through 21. And this is for geometry. This is for the midterm. We're going off of the spring midterm review. So, first up, number 9 talks about the order of the sides of the triangle. Well, and the order of the angles from smallest to largest. Real easily, remember all of the interior angles of a triangle need to equal 180. So working that out, you end up with 68 degrees up here for angle E, which means angle F is the smallest. Then we go angle D, and then we go angle E. So there's the order of the angles in order from smallest to largest. Now, remember the sides and the angles have that relationship. So the smallest angle is going to have the smallest opposite side. Smallest angle, the side opposite that angle is going to be the smallest. So EF is going to be the small, or ED, I can't read, ED, my bad, is going to be the smallest side. Then 66 degrees and its opposite side, which is EF, is going to be the next one. And then the longest one is opposite the largest angle, which is DF. Same thing over here. I've got angle E as my smallest angle. I've got angle F is my next smallest angle, and angle G is my largest angle. Same thing. Smallest angle, its opposite side is going to be smallest. So FG, that was the 36, so there's the opposite side of angle at 36. So FG, then the next one, EG, and then the last one, EF. Okay, state if the three numbers can be measures of the side of a triangle. Remember triangle inequality? The sum of any two sides has to be greater than the third side. So the sum of these two sides, 31 plus 28, has to be greater than 49. The sum of 28 plus 49 has to be greater than 31. And the sum of 31 plus 49 has to be greater than 28. In this case, they all are, so this one is yes. Same here. Sum of these two has to be greater than 35. Sum of these two has to be greater than 30. Sum of these two has to be greater than 26. They all are, so yes. Here we go, we're talking about our special right triangles, 45, 45, 90, 30, 60, 90. Remember, the ratios is the square root of 2 times x times the square root of 2, and, got those backwards, hold up. This is 1, 1, and x times the square root of 2. There we go, that's the correct ratios. So we've got x, square root of 2x. The hypotenuse is always going to be the longest one. X times the square root of 2. So if this side is square root of 2, and I know this longer side is whatever this side is times the square root of 2, then I know that that side right there, this x, sorry I used the same variable multiple times, is equal to the square root of 2 times the square root of 2, which is just 2. 14, again, same thing. This is x, this is whatever x was, that side, times the square root of 2. So if I know this side was 3 radical 2 over 2, I can multiply that by radical 2, and that will give me what this side is. Radical 2 times radical 2 just gives me 3 times 2 over 2. 2's cancel, 3. So A is equal to 3. And in this case, so that was A. B, those were the same. So B is going to equal to 3 radical 2 over 2. And here, Y is the same as what was here, so Y is equal to radical 2. 30, 60, 90 degree triangles, our ratio is 1, or just x, to x, square root of 3, x. So if this one is what number times the square root of 3, if this side is x times the square root of 3, and I have 4 times the square root of 3, then x equals 4. And if this side is 2 times whatever this side is 8. Same here, 1 or x, 2 x, square root of 3 x. Well, if I know this side is 2, 2 times what is 2, I know x has to equal 1. If I know this side is whatever that is times the square root of 3, I know 1 times the square root of 3 is just square root of 3. Again, I'm going over these really quickly, I'm not reteaching this, I'm just going back over it, so you saw how I got my answers. Find all of the missing information in the right triangles. This is right triangle trig. This is my SOHCAHTOA. Like I said, memorize SOHCAHTOA. Dream SOHCAHTOA. Just have that implanted. SOHCAHTOA, sine, opposite hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. SOHCAHTOA. So in this case, I have 62 degrees. I have the adjacent angle, or I have the opposite angle, and I have the hypotenuse. So the sine, opposite hypotenuse, of 62 degrees is equal to opposite over hypotenuse. Cross multiply, x times sine of 62 degrees, is equal to 17 times 1, if you will. Divide both sides by the sine of 62 degrees. X is equal to 17 divided by the sine of 62 degrees. There's your exact answer. If I say an approximation is okay, then you can plug that into your calculator and you end up with 19.25. So that's what x is. That length of the hypotenuse is approximately 19.25. 17, 18, I've got 64 degrees. I've again got opposite and hypotenuse. So sine of 64 degrees is equal to opposite over hypotenuse. Cross multiply again, work that out, and I end up with x is equal to 18.91. Here, I've got 29 degrees. I've got adjacent now and hypotenuse. X is the adjacent, hypotenuse is 19. So the cosine, adjacent and hypotenuse, of 29 degrees is equal to adjacent x over hypotenuse. Cross multiply, I get 19 times the cosine of 29 equals x times 1. And 19 times the cosine of 29 is 16.62. Approximately is equal to x. That's an approximate 2. And that's an approximate 2. So there's 19s, there's 17s, there's 18s. 20, again, I've got 27 degrees, and again, I've got opposite, and I've got my hypotenuse. So the sine of 27 degrees is equal to opposite over hypotenuse. Cross multiply, 20, I end up with x is equal to 8.17. 21, I've got 15 degrees. I've got my opposite and adjacent, or opposite and hypotenuse. So sine of 15 degrees is equal to opposite over hypotenuse. Cross multiply, use your calculator, you get 4.66. Is approximately equal to x. There's part, what are we on, 4? Enjoy, we'll be part 5, just a few minutes.